Voice of Reason Hotline, how may I help you?
Hi, my family's talking about how climate change is a hoax again. Can you help?
That is unfortunately a very common call we get. What are they saying?
They're saying the climate has always been changing and now is no different.
So, part of that is true, but the short answer is no. Let me give you some information to help.
So, when your family is talking about climate change in the past, what they're actually referring to is orbital cycling. We can break down all variations in our Earth's past climate into two phases: interglacial and glacial periods. As the name would suggest, glacial periods are defined as having colder global average temperatures, whereas interglacial periods have warmer average temperatures. We can also characterize glacial periods by the extent to which ice sheets grow, and we can quantify interglacial periods by how much glacial melt occurs.
The last glacial period ended around 15 kiloannum before present, and that period is commonly referred to as the Ice Age. The current interglacial period we're in is known as the Holocene, and it began approximately 11.7 kiloannum before present.
It is important to note that both of these periods will last thousands of years. For example, the Ice Age lasted over 100,000 years, and this will become more apparent when we look at a graph of orbital cycling.
This is a figure demonstrating orbital cycling over the past 400 kiloannum before present from an ice core in Antarctica. I'm going to point out a few of the most recent interglacial and glacial periods.
This area on the graph of global cooling is known as the penultimate glacial period. It began around 194,000 years ago. Next, we have the Eemian interglacial period, which began around 130,000 years ago. This was the last interglacial period before the one we are currently in. The Upper Pleistocene, often colloquially referred to as the Ice Age, was the last glacial period to happen on Earth. It ended around 11,700 years ago. Once again, our current interglacial period is the Holocene. The Holocene will be the first period forced to endure the rapid impacts humans are inflicting on Earth's climate. So you may be wondering from the graph, why is delta 18O on the y-axis? The short answer is that delta 18O is actually a very good proxy for temperature. Other common, well-studied proxies for temperature include carbon dioxide, methane, and benthic foraminifera. But for now, I'm going to specifically explain the delta 18O proxy. In the ocean, there is a mix of 16O and 18O. Since it is easier to evaporate lighter isotopes, 16O is preferentially evaporated into clouds. These clouds are transported over land and eventually precipitated out. These lighter isotopes will then be deposited in the form of ice over the poles. The process of selecting 16O over 18O is known as fractionation, and it's the reason why we can use delta 18O as a proxy for temperature. It's not important to memorize this formula, but I wanted to point out that delta 18O calculation is merely a ratio of 18O over 16O of your sample over 18O over 16O of a standard. Going back to glacial versus interglacial periods, it all comes back to temperature. When temperatures are low during glacial periods, the amount of moisture the air can hold decreases. During interglacial periods, the air can hold more moisture due to higher temperatures. Therefore, during glacial periods, we see more deposition of 16O in ice, and the ocean becomes more concentrated with 18O. Conversely, during interglacial periods, 16O becomes released from the ice, causing the oceans to become lighter. And this is the fundamental basis for how proxies work. We use data already stored by the Earth to reconstruct past climate conditions. Getting back to the original question, we first want to understand why these variations in the Earth's climate exist. Luckily for us, we don't have to wonder. A century ago, Milankovitch discovered three key effects of the Sun's relative position to the Earth on climate. They are as follows. Eccentricity is the shape of Earth's orbit around the Sun. The Earth doesn't travel in a perfect circle every time it goes around the Sun. Over time, the force of gravity from Jupiter and Saturn distort Earth's circular orbit to be slightly elliptical. Obliquity is the angle Earth's axis of rotation is tilted as it travels around the Sun. When the angle of Earth's axial tilt increases, deglaciation begins and an interglacial period follows. As the tilt decreases, the glacial extent increases and we observe glacial periods. When the Earth rotates, it wobbles upon its axis. This wobbling effect is due to tidal forces that cause the Earth to bulge at the equator as a result of the gravitational pull from the Sun and Moon. When these small changes operate together, they can have major implications on our climate over long time spans. Later, Milankovitch created a mathematical model using these three cycles to replicate surface temperatures over the past hundreds of thousands of years that has been well accepted by the scientific community. Now, let's look at how recent warming compares.
This is a figure from the Vostok ice core in Antarctica showing carbon dioxide as well as various other proxies over the past 400,000 years. As you can clearly see, carbon dioxide levels are literally off the charts. Concentrations are also increasing at a rate higher than ever recorded before. It's important to note abrupt warming events are nothing new, and we know the ramifications of them. Well, to some extent at least. They have caused all of the major mass extinctions, sea level rise, and ocean acidification. But this time the climate is being changed by humans in a way it has never before. The next figure demonstrating recent change is from the Mauna Loa Observatory in Hawaii. Set up high on the slopes of a volcano to get representative data, it constitutes the longest record of direct CO2 measurements we have of the atmosphere. The bottom line is that we are in unprecedented times, and we will continue to see more severe impacts around the world.
Those last graphs are terrifying. I don't know how anyone can dispute evidence like that.
Well, I hope your family will accept the evidence you present to them. We certainly don't need any more people spreading misinformation on Facebook.
Definitely. At least this should make family dinners more interesting.
Feel free to call back anytime with other common issues such as anti-maskers, flat earthers, anti-vaxxers, etc.